Welcome back. My name is Athena from Dreamforge Academy, and I will guide you through this lesson. Here's a day you only lose once. Somebody pastes your app's address into their assistant. The sign-in page appears, they type the password they already use, a consent screen names the assistant and lists what it may do, they press allow, and the browser lands back with a tick. 5 steps, all green. Then they ask the assistant to do something real, and it says it can't reach your app. Nothing in that sequence looks like a configuration problem, and that's where the day goes. The fault is 5 strings that must match character for character, and nothing in your stack compares them. The assistant starts with one thing, the address somebody pasted. It posts to that address and gets a 401 back. The refusal carries a header naming the scopes it needs and pointing at a document that describes the resource. It fetches that document, your canonical address, the token issuer, and the scopes you understand. From there, it fetches the authorization server document for the authorize, token, and registration endpoints. Only then does a browser open and a human get involved. Sign in, consent, token. 6 of those 7 steps are machines talking to each other with no key and no configuration. 3 rules about those documents, all learned expensively. Publish them at more than one path because clients disagree about where to look. Make the second route a re-export of the first, never a copy, or they'll match today and drift apart by next year. Leave Discovery CORS open, since a browser client fetches it from another origin. Give the tool endpoint none. Then the 5 strings, your valid audiences, the resource field, what your verification insists on, what the person pasted, and your public address. A mismatch shows up only on the first tool call. Warn an admin in 1 sentence. A startup throw runs during the build and takes the whole app down. Point these at your own deployed app. The first 3 lines fetch both copies of your authorization server document and compare them byte for byte. The next fetches the protected resource document, and the last posts to your tool endpoint bear so you can read the 401 challenge it sends back. 3 settings decide whether any of this holds. Anonymous client registration stays on, because the assistant registers before anyone has signed in, and registration creates a row, not access. Set the rate limit flag explicitly. It defaults to production only. And write every scope list out longhand, never as a spread of another list. Check these with your own eyes. The 2 authorization server documents compare as identical. The bare post returns a 401 naming every scope you advertise. The tool endpoint sends no access control allow origin header, while the discovery documents do. Decode a real access token from a connected assistant and read the audience claim. It must match the resource field you just fetched, scheme included, no trailing slash. Then call registration in a loop until a 429 appears, and find the counter row in your database. On a serverless host, name the forwarded for header that carries the real caller address, or every request on the planet lands in 1 bucket. The grant is a row you can delete, which beats a key that lives forever in a config file. Sign in green plus a 401 on the first call means the audience and the resource disagree. Leave the registration privilege callback off. It only runs when a session exists, so it blocks signed-in users while doing nothing about anonymous callers. Keep offline access in both the advertised list and the registration allowed list. Change your domain and every connected assistant reconnects because its token still names the old host. Your assignment is a 1-page ledger, 5 rows, 1 per string with where it's set, its full value, and how you measured it. Thank you for watching. Follow along using the course material and complete the lesson assignment. I will see you in the next lesson.